this is the only thing I need. The general law that I will apply, which in this case are two equations. Step number 5. A very important step. This is critical step. Like this is critical, this is critical. Step number 5. The step number 5 is the following. Find what is the algebraical addition of all forces. Algebraical, very important word. Algebraical addition of all forces along the axis in question. What is the meaning of algebraical addition? That if the forces are pointing upward, will be positive forces or negative forces. Pointing upward and the arrow is upward, like in this case. That is positive. And this will be negative. But if the object is moving downward, downward will be my positive direction. Anything pointing downward will be positive. Anything pointing upward will be negative. This is what I mean by algebraical addition. In this case, I want to find what is this. I want to dissolve this or disclose this by components. This doesn't tell me anything. This is telling me that all forces make the object not move along X. This is not meaningful for me. I need to see inside that algebraical addition what is going on. And who tell me that is the free body diagram. So what is the algebraical addition of all forces along X? From here, what can you say? The tension 1 along X is positive. Is that clear? And then minus tension 2 along X equal to what?
0.
What we have here. This is my first equation. This is this. But I have a second equation. I also need to find the algebraical addition. So this step, I will put it as find the algebraical addition of all forces along the axis in question. This is the step. This is the algebraical addition of all my forces along X. What will be the algebraical addition of all my forces along Y? We look at the free body diagram. And let's look only along Y. What is going on along Y?
Tension 2, Y.
Tension 2.
Y.
What else?
Plus T1, Y.
Plus tension 1 minus FG equal to what?
0.
0. This is what I call algebraical addition of all forces along Y. Number 6. Now, the next step is substitution and calculation. Now, we are ready to substitute and calculate. And this, which I didn't put here, find algebraical addition. Because it's critical, I will put it there, which I didn't say what will be. Let's substitute and calculate. Everybody remember what is T1X. If the angle is from the x-axis, what will be T1 along X? T1 cosine theta. 1. T1, this is a continuation of that. T1 cosine theta 1 equal to what? If I move this to this side, equal to T2 cosine theta 2, right? What do we have from here? What can we find? Do we have T1? Do we have T2? But we have theta 1 and theta 2. At least I can find symbolically what will be T1. Right? Which is, if you want to substitute, you can put number. How much is theta 2? 30, right? And theta 1? Good.
No, theta 1 is
Yeah,
30.
I made a mistake here. Because this is tension 2, let me just put tension 2, and this is tension 1, okay? Theta 1. It was my mistake. Okay, so what I did, T1 in terms of T2, is that right? But I cannot solve it. You have one equation, and you have two unknowns, I cannot solve it, right? I can solve it. What can I do? I have to have a second equation. What is my second equation? No, I have a second equation there, along Y. What is my second equation? Tension 1 or tension whatever. This T2Y, what is that? T2 sine theta 2 plus what? T1 sine theta 1 equal to what? Mg. I can move to this side. I need to find one, and then I need to find the second. How is called this in math? You need to solve for what? When you solve for two unknowns, how is called that? Elimination or substitution method. And this is solving what? A system of equations. You solve a system of equations of two unknowns in math. The same thing. So, since T2, I have T1 here, I can replace it. So T2, right? Sine theta 2 plus, I will replace T1, T2 cosine, 30. Let me just put number now. I don't like to put number, but just to see. Sine of, what was T sine theta 2? 30. T2 cosine 30 divided by what? Cosine 45, sorry. Time what? Sine what? 45. Equal to what? How much is mg, right? How much is the mass? 10 kilograms, and times 10 is 100. I have T2 here and T2 here. What can I do with that? Sine 30, which is 1/2, 0.5, plus cosine 30. Which is 0.63, or how much is that? Anyway, the square root of, this is the square root of the square root of 3 over 2. 0.866. Sine over cosine 45, which is cotangent of 45. That will be 1 because the square root of 2 over 2 over the square root of 2 over 2 cancels out. So I get 1 equal to 100. This is my T2. So my T2 will be 100 divided by 0.5 plus 0.866. You can find T2. Any question? Now we have T2. What can we do to find T1? We go backward, or we go back to here, and we find T1. Any question? This is math. This I cannot teach. This is what I teach. Step number 1, set up. Step number 2, row diagram. Step number 3, free body diagram. Step number 4, find which Newton law we will apply and along which axis. In this case, was a Newton first law in both axes because the forces are along both axes. Then I find the algebraical addition of my both equation then I substitute on calculus. From now on is math. If you follow this algorithm for every problem dealing with the Newton laws, where you have to find forces, individual forces, if you follow this, you succeed. If you don't follow and you want to be smarter or faster because, oh, I know everything, doesn't work. That physics doesn't work that way. They